Okay, class, in this lesson, we are going to define the basic words or vocabulary for savings accounts and then learn to compute simple interest using the simple interest formula. So let's go ahead and get started with some definitions. So a savings account is an account that the bank pays interest for the use of the money that you deposit in the account. And there are essentially three major types of savings account. The first one is the statement savings account, and this is the most common one. You're going to receive monthly statements similar to your checking account. Some banks may require a minimum balance deposit or a fee will be charged. And then the second type of savings account is called the money market account. And a money market account typically pays a higher interest rate than the statement savings account. However, they will require a higher initial deposit as well as higher minimum balance. Now, the requirements will vary from bank to bank, but these are the general characteristics. And then you may be limited to a certain number of transactions for money market. That is certainly true for statement savings. I believe today you're limited to 7 withdrawals from your statement savings account before a fee is charged. You can make as many deposits as you want. So for the money market account, there may be some limited number of transactions. And then the third type of savings account is what's called a certificate of deposit, or CD. This type of account essentially guarantees payment of fixed interest rate until maturity. So essentially what you're going to do is commit a certain dollar amount, and the bank usually will have a minimum requirement, and you're going to give them the money, and it's going to sit in there for a committed period of time. It could be 1 year, 2 years, 5 years, whatever the term may be, and you're going to keep it in there for that time, and then at the end of that period, the bank will pay a certain amount of interest for the deposit. You cannot make additional deposits or withdrawals during that time unless you incur some sort of penalty. Okay, so those are the three types of, or three major types of savings accounts. There may be others depending on the bank that you bank with, but these are the most common types that you will encounter. Okay, now interest is based on interest rate and principal, or your balance, right? So that's the interest is the amount of money that you earn, and the annual percentage rate, or also known as APR, is the yearly interest rate. So in a given year, this is how much interest rate you would earn or that a bank would pay you, and it's usually expressed as a percentage, okay? Now, there are two classifications of interest. One is called simple interest, which is what we will cover in this lesson, and then you should also be aware that there's also another type of classification, which is called compound interest, and I will cover that in a different video. But for the sake of learning the simple interest formula, that is defined as I is equal to PRT, where I is the interest amount that you earn, P is the principal or the initial money that you put in, R is the annual interest rate. Okay, note that it's an annual interest rate and it's expressed as a decimal, and then T is the number of years. Okay, T is the number of years. And I emphasize years because in a little bit later, there will be a couple examples where we will talk about months, and I will show you how to express those in terms of years. All right, now shifting gears, a little bit similar to simple interest, however, this is a little bit different, is called the arithmetic sequence or arithmetic sequence. And it is normal for people to, at least back in the day, before we went to digital banking, it was normal for people to collect coins from expenses that they incur every day. Okay, so the example here is Jose typically buys a cup of coffee for $1.50 each morning. He pays for it with $2 but what he does is he takes the 50 cents left over and he puts it in a jar at home at the end of each day. Sort of his way of kind of saving up for the difference. This problem can actually be modeled by an arithmetic sequence, and that is as follows. A sub n, okay, so the total amount that Jose would have is equal to the initial amount that's in the jar plus n minus 1, n being the number of terms, or in this example, the number of days, minus 1, times d. That's the common difference. So in this case, the coffee was $1.50. He paid for it with $2 single bills, so the difference is 50 cents. Okay? So what this means is using this equation, we can determine how much Jose will have at any given day. So we could say, well, in 10 days, how much will he have? In 20 days, in 99 days, and 148 days, how much will he have? This is the equation that we will use. Okay, so let's go ahead and start with an example similar to the Jose example, where Lisa has a glass jar in her office that she uses to collect coins. So in the beginning, she starts off with $11.25 in coins that she already has. So she throws that in the jar. And what we are told is that she pays for her commute to work each day. And at the end of each day, she receives 70 cents in change. Okay? So she's going to add the 70 cents into the glass jar each workday. And the question here is, how much will she have after 100 workdays? Well, we would start with the following formula, which is the arithmetic sequence. A sub n is a sub 1 plus n minus 1 d. Okay? So we're looking for a sub n. We know a sub 1, according to this problem, is $11.25. That is what she starts out with in the jar. And we also know that we are dealing with 100 workdays, and the difference that she receives after paying for her commute is 70 cents. Okay? Go ahead and note that. And so we can go ahead and plug those values into this equation. 11.25 plus 100 minus 1 days times 0.7. Okay, now if we punch that into the calculator, we would get $80.55. Okay, so after 100 work days, Lisa is going to have this much in her jar. And so what's nice about this formula is we can determine what the final amount will be for any number of days that we're talking about. So in this example, we're looking at 100 work days, but we could say, well, what is she going to have in 135 days or 162 days? We can go ahead and change the n value and calculate that and get an actual dollar amount. Okay? All right, so that's how you use an arithmetic sequence or arithmetic sequence, depending how you want to pronounce it. So let's go ahead and move on to example 2. All right. So in example 2, we're now gonna go back to money here in simple interest. But before we go to simple interest, we want to make sure that we understand that interest rates can be expressed as a fraction, and it could also be expressed as a decimal. So we need to understand how to convert or convert one to the other so that we're comparing apples to apples or decimals to decimals in this case. So in this example, Grace wants to deposit $5,000 in a CD for a period of 2 years, and she's looking at interest rates. She's comparing it between 4 banks, 3 that are local banks and then 1 that's an online bank. And so we are to write the interest rates in ascending order and find out which one pays the highest interest rate for a 2-year CD. Okay, so we see that Chase pays 1.25%, and that really works out to 1.25% in terms of decimals. Wells Fargo also pays 1 3/8%, and converting that into a decimal works out to 1.375%. And then Bank of America and Juniper have their interest rate already stated in percentage terms, so we don't need to convert those. So let's go ahead and rank order this from smallest to largest, okay, in terms of percent. So in comparing these numbers, okay, we see that Bank of America offers the lowest, okay? So I'm going to call this B of A, and that's at 1.22%. And then we look at the next, we see that Chase offers 1.25%. So we're going to go ahead and write that down. Chase is 1.25%. And the next one is Juniper. We've got 1.3%. Juniper, 1.3. I'm going to call it 1.30%. So we have the same number of places after the decimal. And then the last one is Wells Fargo. Okay, we'll call that Wells. And they are paying 1.375%. Okay, so we've got this in ascending order: 1.22, 25, 30, 375. And so obviously, the bank that pays the highest interest is Wells Fargo. Okay. All right, so let's go ahead and move on to example 3. Now we're going to go into simple interest formula. We're told that Yaniri's savings account must have at least $500 in it, or she is charged a monthly fee of $4. This is not the simple interest, but another scenario as we lead into simple interest. Her balance was $716.23 when she withdrew $225. What was her balance after the withdrawal? Okay, so we're told that her balance was $716 and she withdrew $225. Okay, and so if we subtract the $225 from the $716.23, we find that her account balance drops down to $491.23. This amount is below the minimum of $500, so she's going to get charged a $4 fee. So we're going to go ahead and subtract that from the balance. So her balance after the withdrawal will be $487. Okay, so this is something that you're going to have to keep track of when you have your own account. And the only way to keep track of it is to watch the transactions online or look at your bank statement. Okay? Banks are notorious for charging you fees, and if you're not aware of those fees, you may not be realizing that you're losing money in your account. So one of the things you're going to want to do is avoid any type of fees that the bank charges you. Okay, so let's go ahead and go on to example 4. This is a simple interest example. So here we have Mitchell, who deposits $1,200 into an account that pays 1.5% simple interest. He keeps the money in the account for 3 years without any deposits or withdrawal, so no transaction. So the question is, how much is in the account after 3 years? Okay. Remember that we're looking at how much is in the account after 3 years. We need to think about that for a second and keep that in the back of our minds, okay? So we're going to start with the simple interest formula, which is I is equal to PRT. So we're calculating I, so we want to know what the interest amount is, and that's going to be based on the $1,200 that Mitchell deposits times the rate, which is going to be expressed in decimals. So that's going to be 0.015. That's your 1.5%, and he keeps it in there for 3 years. So let's go ahead and punch that in to the calculator, and when we do, we find that the interest is $54. Now that is not the answer, right? Remember, I told you to remember the question, how much is in the account after 3 years? So we have to take this interest amount, add that to the initial deposit to get our answer. Okay, so 1,200 plus 54 means that we're going to have $1,254 in the account after 3 years. Okay, so let's go ahead and move on to example 5. We're now asked to determine how much simple interest does $2,000 earn in 7 months at an interest rate of 2%. Okay, so we want to know how much interest is earned with $2,000 in deposit or starting amount after 7 months at a rate of 2%. We are to round to the nearest cent. Okay, so whenever we need to round to the nearest cent, that means we have to round to 2 decimal places after the decimal. So let's go ahead and start with our formula again for simple interest. I is equal to PRT. Our principal is $2,000. Our rate is going to be 0.02, expressed as a decimal. And then our T in the equation should be expressed in years, but we're told that we need to know how much this amount earns in 7 months. So we have to take the 7 months and divide that by 12, right? So that is the proportion of a year that we are earning the simple interest. And so if we go ahead and plug that in to the calculator, we'd find that that amount is $23.33. Okay, so that is our answer. This is how much simple interest that is earned from a starting point of 2,000 for a period of 7 months at a rate of 2%. All right, let's go ahead to the next example. Now we are asked to determine how much principal must be deposited to earn $1,000 in simple interest in 2 years at a rate of 1.3%. Okay, and we need to round this to the nearest cent. So again, we start with the equation y is equal to PRT. Okay, let's go ahead and plug in what we know. Okay, so we are told that we want to earn $1,000 in simple interest. So that's going to be our I, 1,000. Okay, we need to figure out our principal, so we don't know what that is. We're going to just call that P for now. And then our rate is going to be 0.013. Okay, that's our 1.3%, and this is over a period of 2 years. Okay, so now we need to solve for P. So we're going to take 1,000 and divide that by the product of 0.013 times 2. Okay, and punching that in to the calculator gives us $38,461.54. So this is how much we need to have to begin with, or how much we need to deposit in order to earn $1,000 at a rate of 1.3% for 2 years. Okay, hopefully all of this made sense to you. If any of this was confusing, please go back to the beginning of the recording and listen to it again. Thank you.